Now, question number two, this is related to rate of reaction, and it says that a student wants to investigate the rate of hydrolysis of methyl methanoate. So, methyl methanoate is an ester, and we are hydrolyzing it. On hydrolysis, it will produce methanoic acid and methanol. The reaction is catalyzed by dilute hydrochloric acid. Hydrolysis of ester needs a catalyst, and we are using dilute hydrochloric acid as a catalyst. The amount of methanoic acid produced as the reaction progresses can be monitored by titration with aqueous sodium hydroxide. So, the amount of methanoic acid that will produce, this can be determined by reacting it with sodium hydroxide. So, acid base reaction will occur between methanoic acid and sodium hydroxide of known concentration using thymolphthalene as an indicator. To determine this, the volume of sodium hydroxide needed to neutralize the H plus ion from the catalyst needs to be found beforehand. Now, this is very important because we are using HCl as a catalyst and hydrochloric acid is a strong acid. So, obviously, if we add sodium hydroxide, it will initially react with HCl, and once HCl will be completely neutralized, then it will react with methanoic acid. So we have to find out the amount of NaOH or the volume of NaOH which is needed to neutralize the H plus ion from the catalyst. All right, now the student uses the following procedure. Add approximately 150 cm cube of iced water to a 250 cm cube conical flask A. So let's say this is conical flask A. This is conical flask A, and it contains 250 cm cube of 150 cm cube of iced water. So let's say this is 150 cm cube of iced water, and this is conical flask A. This is conical flask A. Add 200 cm cube of 0.250 mole per dm cube HCl to a 500 cm cube conical flask B. Then we took another conical flask. This is another conical flask, and we add 200 cm cube 200 cm cube of 0.250 mole per dm cube HCl. So this is conical flask B, which contain 200 cm cube of 0.250 mole per dm cube HCl. Conical flask B is the flask in which the reaction takes place. Transfer 2 cm cube of 0.250 mole per dm cube HCl from B to A. All right, so we'll extract 2 ml or 2 cm cube of acid and we'll transfer it into this A. Carry out a single titration of the contents of conical flask A with NaOH of known concentration. So this is uh, the chemical reaction which we perform to calculate the volume of NaOH required to neutralize the H ions present due to hydrochloric acid, due to catalyst. Right. So this is the first experiment which we'll do with HCl and sodium hydroxide just to find out the volume of NaOH required to neutralize the H plus ion from HCl. Next step, step 4, add 10 cm cube of methyl methanoate to conical flask B. Now we'll add 10 cm cube of methyl methanoate, 10 cm cube of methyl methanoate to conical flask B. Swirl the reaction mixture and immediately start a stopwatch. So reaction will now start. Methyl methanoate will hydrolyze and it will convert into methanoic acid and methanol in the presence of hydrochloric acid. After 1 minute, transfer 2 cm cube of the reaction mixture from conical flask B into conical flask A. Right, just like step 3, in step 5, we'll transfer 2 cm cube of the reaction mixture from B to A, but this time it would contain methanoic acid and HCl both. All right, this time it contains both the acids. So initially it will react with HCl, sodium hydroxide will react with HCl, and then it will react with methanoic acid. Carry out a further single titration of the contents of conical flask A against NaOH. Do not empty the contents of conical flask A between titrations. After 10 minutes, transfer 2 ml of the reaction mixture from conical flask B into conical flask A. After 10 minutes, we'll repeat the process. Titrate the contents of conical flask A against sodium hydroxide. So the same process will happen again. Repeat step 6 at intervals of 10 minutes for 1 hour. Right, so it means we have to take 6 readings. Each after 10 minutes, we'll take 2 ml of solution from B and transfer it into A, and then we'll titrate it with sodium hydroxide. State which step is used to determine the concentration of HIN from the catalyst in the mixture. So this would be step 1. Step 3, sorry, step 3. In step 3, we transferred 2 ml of 0.25 mole per dm cube HCl from B to A. So that means that was only HCl, no methyl methanoate was present in conical flask B. So step 3 is used to determine the concentration of H plus ion from the catalyst in the mixture. So this is step 3. The iced water in conical flask A is used to significantly reduce the rate of reaction. Suggest 2 reasons why the rate of reaction is significantly reduced when the reaction mixture is transferred to conical flask A. Suggest 2 reasons why the rate of reaction is significantly reduced. So the first reason is lowering of temperature, because we are using iced water. Uh, at very low temperature, the kinetic energy of particles will decrease and no further reaction will take place. So due to the lowering of temperature. The first reason is lowering of temperature, and the second reason is we are diluting it. It contains 150 cm cube of iced water, right? And when we add 2 ml of HCl, so obviously that 2 ml of HCl, when it is added into such large amount of water, it will get extremely diluted. And due to that dilution is one of the factors which controls the speed of reaction. So if we dilute the solution, reaction will become extremely slow. So reaction to what happen is dilution occurs. Sorry, the second reason is dilution occurs on adding acid into on adding acid into such large amount of water. Table 2.1 shows the readings taken by the student. The titration step 4 to 7 shows the volume of NaOH needed to neutralize both the H plus ions from the catalyst HCl and from the methanoic acid produced in the reaction. Volume of NaOH needed in cm cube to neutralize H plus ion from catalyst is 11.40 cm cube. So this is the volume of NaOH needed to neutralize the H plus ion from the catalyst, 11.40. Volume of NaOH in cm cube used to neutralize H plus ion from methanoic acid at time t is Vt, and the volume of NaOH in cm cube needed to neutralize H plus ion from methanoic acid at 60 minutes is V infinity. The student forgot to take reading 5. Reading 5 is missing. You can see here, reading 5 is missing. Complete table 2.1. So we have to fill the table for Vt, which is the volume of NaOH needed to neutralize H plus ions from methanoic acid, Vt. So this is the total volume of NaOH needed to neutralize total amount of H plus ion, and the amount of volume of NaOH required to neutralize H plus ion from catalyst is 11.40. So therefore, Vt, or the volume of NaOH required to neutralize H plus ion from methanoic acid, this would be equal to 12.60 minus 11.40, the volume of NaOH required to neutralize H plus ion. So this would be equal to 1.20. 1.20, 12.60 minus 11.40. Similarly, 17.70 minus 11.40, this would be equal to 6.30. The third reading is 8.50, then 10.70, 13.50, 14.50. Next is V infinity, which is the volume of NaOH required to neutralize H plus ion from ethanoic acid at 60 minutes. So V infinity minus VT, V infinity minus VT, that is, and this is the volume of NaOH required to neutralize the H plus ion from methanoic acid at time 60, right? So 14.50. So this would be equal to 14.50 minus 1.20. So this would be 14.50. This is V infinity minus 1.20. So this is equals to V infinity minus this is V infinity, this is VT, and the answer is 13.30. Likewise, we get 8.20, 14.4050 minus 6.30, 6.00, 3.80, 1.00, 0.00. Right. So this is now we have completely filled the table. Identify the independent variable. So the independent variable in this experiment is time, because we are measuring the concentration at different times. So that means time is the independent variable. Time is the independent variable. Identify one variable that needs to be controlled apart from concentration and volume of solutions. Temperature, obviously. Temperature affects the rate of reaction, so temperature need to be controlled. Reading 2 should have been taken at 10 minutes and not at 13 minutes, because there is a difference of 10 minutes in every reading, but reading 2 is at 13 minutes, so it should be taken at 10 minutes. State whether this result should have been included or not. Explain your answer. Yes, this will be included because it is following the trend. As the time is increasing, the VT, the amount, the volume of NaOH is also increasing, because with the passage of time more methanoic acid will produce. So yes, this is reliable, and we can use it as the volume of NaOH or titer is accurate and following the trend, right? So as time would increase, more volume of NaOH would be required. Plot a graph on the grid in figure 2.1 to show the relationship between V infinity minus Vt and time. Use a cross to plot each data point. Draw a line of best fit. So this is the points we have plotted, right? These are the points on y-axis. We have V infinity minus Vt, and on x-axis it is time taken in minutes, right? So V infinity minus Vt is this column, the last column, and time is 1 to 60. So this is the line of best fit. We have plotted the graph, and now the next question is reading 5 was not taken. Use the graph to predict the total volume of NaOH needed to neutralize the total amount of H plus ion at 40 minutes. So at 40 minutes, this would be the amount. V infinity minus Vt would be 2 2.3 2.30. V infinity, this would be V infinity minus Vt. They're asking us to predict the total volume of NaOH needed to neutralize the total amount of H plus ion. So this is V infinity minus Vt, and V infinity is 14.50. So 14.50 minus Vt is equals to 2.30. So therefore Vt would be equal to 12.20. 12.20. This is the Vt. This is the volume of NaOH required to neutralize the moles of methanoic acid, or the number of H ions, number of H ions from methanoic acid. And they're asking to predict the total volume. Total volume means the volume of NaOH required to neutralize H plus ion from methanoic acid and H plus ion from HCl. So H plus ion from HCl needed 11.40. So all we have to do is add these two values, 12.20 plus 11.40 plus 11.40, and this is equals to 23.60. 23.60.